So Apple just dropped a really fascinating paper on a project they're calling Manzano. And what it does is it goes right after one of the biggest headaches in AI today, trying to build a single model that can both understand the world around us and create brand new things in it. And the solution they came up with, it's actually surprisingly elegant for a problem that's had researchers stumped for a long, long time.
Okay, let's get right to the heart of it with this one question. Think about it. Can one single AI be both a brilliant analyst, super logical, precise, able to reason through complex data, and at the same time, be a master artist, completely creative and imaginative? For a long time, that's kind of been the holy grail for multimodal AI.
And these two images just nail that difference perfectly. On the left, you've got the analyst. Its job is to look at that complex chart and pull out very specific pieces of information. That takes a deep, meticulous level of understanding. But then, on the right, you have the artist. Its job is to dream up something that completely ignores the rules of reality. That's pure generation.
Now here's the kicker. Historically, these two skills have been basically at war with each other inside an AI model. It was a zero-sum game. The very things you would do to make an AI better at understanding that chart would actually make it worse at generating that surreal elephant, and vice versa. This trade-off has been a fundamental roadblock in the field for years.
So to really appreciate how Manzano gets around this, we first need to understand the root of this conflict. Let's call it AI's two-brain problem.
At its core, it's pretty simple. Image understanding is all about deconstruction. It's like taking an engine apart to see how all the pieces work. You're breaking an image down into concepts and information. On the flip side, image generation is all about construction. You're starting with just an idea and building something brand new, pixel by pixel. They are fundamentally opposing forces.
And this whole conflict begins at the most basic level possible, a step called visual tokenization. Now, that's really just a technical way of saying how the AI reads a picture. It has to translate the image into a language of data, these little things called tokens, that it can actually process. And it turns out the way you decide to chop up that image into tokens has a massive effect on what the AI can do later. And look, this isn't just a theory. The researchers who wrote the Manzano paper say it plain as day in their introduction. They point out that in older models, when you tried to add the ability to generate images, the model's ability to understand them often got worse. So this was a very real, well-documented problem.
So if the problem starts with the tokenizer, it kind of makes sense that the solution would be there too. And this brings us to Manzano's big, clever idea, the hybrid tokenizer.
From a high level, the solution is just beautiful. Instead of trying to build two different AI brains, they use one single large language model. The trick isn't giving it two brains. It's about giving one brain two different ways to see and process the information from a single image.
And the big idea here is so elegant. The model only has to see the image one time through one shared vision encoder. This is incredibly efficient, but more importantly, it means that both the analyst side and the artist side are working from the exact same source of truth.
So path number one is for understanding. This path creates something called continuous embeddings. You can think of these like a really rich, high-resolution digital photograph. They're full of nuance and fine-grained detail, which is exactly what you need for tough analytical tasks, like reading the tiny text inside a document.
Then there's the second path, which is for generation. This one creates discrete tokens. Now, if the first path was a high-res photo, think of this path as a box of Legos. You have a set number of clean, standardized building blocks. Because the model only has to learn how to arrange this limited set of bricks, it becomes much, much easier for it to assemble them into a brand new, coherent image. This is the secret to high-quality generation.
Okay, so we've got the core concept. Now let's zoom out a bit and look at how this all fits together into the full Manzano system.
So the whole system really has three main jobs. First, you have the hybrid tokenizer we just talked about. That's the eyes of the operation. Second, you have a unified LLM decoder, which acts as the brain. It does the heavy lifting, the thinking, and decides what comes next, whether that's a word or one of those Lego-like image tokens. And finally, you have an image decoder, which is kind of like the hands. It takes those visual tokens from the brain and actually paints the final picture. And they bring this whole system to life with a really smart three-stage training recipe. First, it goes through broad pre-training, basically learning the fundamentals from billions of images and texts across the web. Then it moves to a more focused training on higher quality data to really hone specific skills. And finally, it's fine-tuned on curated, hand-picked examples to get really good at following specific instructions. It's this careful process that makes it all work.
So the architecture is clever, the training is intense, but does it actually work? This is the fun part. Let's take a look at the results because the evidence they show is pretty darn compelling.
And this image right here tells the whole story. On the left, a competitor's model tries to generate a sign with text on it, and it's just garbled nonsense. This is a classic problem for generative models, but look at Manzano's version on the right. The text is perfect. This is huge. It proves that its deep understanding of text is directly helping its ability to generate images.
And the performance holds up across the board. This is a radar chart, and it's pretty simple to read. The farther the line is from the center, the better the model did. Just follow the green and blue lines from Manzano. You can see they basically form a bigger shape that swallows the competition. It's not just a one-trick pony, it's a powerful all-rounder.
But what's really wild is how well it does on tasks involving a lot of text. I mean, look at this. The smaller 3 billion parameter version of Manzano isn't just competing with models that are 2, 3, even 4 times its size. It's absolutely smoking them. Just look at that DocVQA score. It's beating a 14 billion parameter model by more than 5 points. That's incredible.
And that right there is the headline number 93.5 on DocVQA, which is a really tough benchmark for understanding complex documents. What this really proves is that by solving that core tokenization problem, Manzano became a state-of-the-art artist without having to fire its world-class analyst. It got to be both.
So you can see how this breakthrough has implications that go way beyond just this one model. It really points toward a future where that hard line between understanding and generating just starts to dissolve. Because when understanding and generation are woven together this tightly, the model can do so much more than just create a picture from a prompt. It unlocks all these amazing and intuitive image editing abilities. Things like changing the style of a photo, removing an object, or filling in a missing piece, all just by talking to it. And you can immediately see why a company like Apple is so interested in this. I mean, this is the kind of tech that could lead to way smarter photo editing on your phone, or a Siri that can actually see and understand what's on your screen. Okay, so let's just quickly recap the big takeaways here. First, Manzano proves that you don't have to choose. A single, unified model is possible without those painful trade-offs. Second, that hybrid tokenizer is the secret ingredient that makes it all work. Third, the design is simple and clean, which means it can scale up really effectively. And finally, its performance on text-heavy tasks is a massive advantage.
And that leaves us with this final, really exciting question to think about. For so long, we've thought of an AI's ability to see and its ability to create as two separate skills that were constantly fighting each other. Manzano shows they can work together in harmony. So now that we're starting to solve that fundamental conflict, what's the next impossible thing that suddenly becomes possible?